Good morning, all of you. It's me, Adnan Gauri, the founder and director of iWorkstation. I welcome you all for the iWorkstation BIM series. It's been a long time since we conducted an event like this, and today I am with one of my friend, Roland Sols from USA. He's currently living in Bali for the past 3 years. Most of the time, he has worked with Ibuku Studio, which is in Bali as of now, a local firm which specializes in bamboo design and construction, and he's going to present you about a very unique design which is in the Bali itself, and it's a completed project. So he's a project architect for the ARC, the Green School, which has even won the 2021 Architecture Master Prize. So along with me is Roland. Welcome, Roland.
Thank you. Hi, everyone. Thanks for having me today, and thanks for joining. I am going to talk a little bit about my experience in architecture, and especially the experience of being from the United States and coming here and working with a very natural material. And I'm hoping that everyone can learn something today, or at least take away some inspiration. So I'm going to share a presentation. Oh, I need to share the screen.
Yeah.
Okay. So I want to talk about, to begin with, a little bit about the current state of the construction industry, because people have been building habitats and buildings for thousands of years, and we all know that. But over the past 200 years throughout industrialization, and especially more recently, we've found ways to make all of our building materials faster and cheaper, which is a good thing. It makes architecture more accessible, but it also has created a result that our building materials lack a lot of tie back to nature. So, for example, with bricks, people used to make mud bricks like you see on the left, and then those were pressed into machines, and then now we have just like fake bricks. It's basically like brick wallpaper, and it's not even doing the structural job of a brick anymore. It's just something to make it look like a version of the past. We've done the same thing with wood. People used to, all over the world, chop down wood and use it as a thermal mass to create really warm buildings. And over time, we've milled that down into regular pieces of wood that are more predictable and easier to ship. And now we have like MDF board, which is just, it's not even recognizable that it's wood anymore. Or we have even vinyl pretending to be wood that we use now. The same thing has been done with stone. We used to carve buildings, whole buildings out of stone, out of the side of mountains all over the world. And that turned into stacking stones, and that turned into creating thin machined versions of stones. And that has now evolved into this lovely plastic piece that you can buy from Amazon and pour concrete into to make it look like you have a stone pathway. And this progression of materials is resulting in a really big environmental impact. If you look at the total global emissions from the building industry over the past several years, in 2014, we had much more carbon emissions coming out of building operations. So actually heating water and making electricity and supporting the building operations was the highest amount of emissions. And then in 2018, we see that spike even further. But then after that, we see that the rise of solar panels becoming cheaper and more accessible means that our building operations, which is turning to mostly electrical and turning mostly to solar electrical, is starting to decrease in that impact. But we don't see that same kind of progression being made in the actual construction materials. So architects have started to realize this, and even cities have started to realize this and offer incentives to developers to use more sustainable materials and more materials that will result in a lower carbon footprint. And one of those is bamboo. And this is exactly why I got into bamboo in the first place, is because it has a huge potential to really shift the entire face of our building industry. It is going through the same process right now that all other natural materials have been through. It's almost an inevitability that we take natural materials and we make them so standard and force them to be better versions of the things that we already have. So we have structural laminated bamboo beams, which are replacing concrete and steel beams. We have pellets of bamboo sawdust that are being used as injection molding aggregate. We have, of course, bamboo flooring, which is a replacement for old growth timber so that we don't have to cut down rainforests anymore to have nice hardwood floors. And we even have some research from a few years ago coming out of Singapore, which was finding a way to replace rebar, steel rebar, with bamboo rebar inside concrete. And they found a way to actually engineer the bamboo to make that possible. This has resulted in a kind of new movement of making vernacular style buildings with old materials. And so we're seeing these pop up all over the world that instead of just engineering these materials into better versions of what we already have, we're looking at, there are some very few architects around the world that are looking at how are these natural materials lending themselves to new forms of architecture, new things that we can look at and be inspired by, new possibilities, instead of creating the same shape of buildings and the same type of buildings that we've always had. How can we actually listen to the natural material itself and let the materiality influence the design? So enter Ibuku, which is the firm that I worked for here in Bali for 2.5 years. They have become the world leader in doing these type of buildings, this modern vernacular style of construction with bamboo. And I was lucky enough to be put in charge of this project, the Archit Green School, which is a gymnasium structure at the Green School here in Bali. It is in total 760 square meters. And this structure was originally conceived by a master of bamboo construction. His name is York Stam. And he and Neil Thomas, who is a fantastic engineer, together worked on this concept design. And York created this idea to create a structure that was based off of and took inspiration from the wings of a bat or from a human rib cage. Within both of these structures in nature, you have very, very thin members that are working in compression, the bones within the bat's wing or the ribs within the rib cage. And they're able to be very, very thin because they are embedded within a stretched membrane. For the bat, it's a membrane of skin. For the human, it's a membrane of muscles and tissue. And because it's stretched in that membrane, those compressive members can be incredibly thin because they don't have to fight bending stress as much. And this is the approach that was taken in this building. So if you look at the overall structure of the building, you'll see that there are almost no trusses in the building. These arches that span are pure arches. There's no trussing involved. And they're very, very thin, and they're held together with these slightly curving grid shells is what we call them, which is basically like a spaced out kind of basket structure. It's almost a woven kind of thing, but it creates a rigid structural flat surface. And this is the result that we have from the interior of the building. If you look at the shape of the roof, how it curves down, it plays a trick on your eye because it looks like it's sagging down and it looks like it's heavy and it's weighing down these arches. But in fact, that structure, it's curving and the axes of these surfaces are curving in two opposite directions. And that is what we call an anticlastic structure. And it creates the it makes the building very rigid. It makes that membrane very rigid, and it helps to redistribute forces within the arches, which means that we can decrease the bending stress of the bamboo down to almost non-existent. In order to pull this off, there was a lot of computer aided design working on this structure, which is a very challenging thing to do. And it's something that needs to be explored much more, is how do we take natural materials in their natural state and reconnect to our ancestors. No matter where you're from, your ancestors have built with natural materials all over the world. So how do we connect with our humanity, and how do we connect with the people who came before us and bring back some of these natural materials, but make it work for our world and make it work for the scale of buildings that we need to be able to build? So what we did was we created, sorry, I'm jumping ahead. We created some structural tests, and we conducted these tests for months. And we built whole sections of the building. So this is a section of one of the arches. You can see there's 6 pieces of bamboo that are bolted together, and they're detailed in a very specific manner. And we tried different structural details, different types of structural connections, and we would test them. And we would measure the water content of the bamboo. We would measure the humidity that day. We would measure, of course, deflection with the load. We would measure how long it took to deflect, how much, of course, how much weight we put on it. And we would take all of this raw data and we would use it to figure out, is this detail better or is this detail better? Or does this bolt work better or does this screw work better? And over time, we were able to exact what was the perfect design detail, the structural detail for this building. And additionally, we took all of these, all of this raw data and we sent it to our engineer. And he was able to take all of this data and sift through it and decode it and engineer the building for a completely new set of rules that we had kind of discovered just through testing. What are these materials actually capable of? And of course, we added safety factors. The engineer added safety factors for wind load, for rain load, for earthquake load, also for workmanship, because it's a natural material and it's not standardized in any way. So there was a safety factor for in case there's a screw missing here or there. You know, a craftsman forgot his coffee that morning, and so he engineered this building to be able to withstand all of these forces. And even when the building was under construction, we were continuing to do testing to see if this grid shell is strong enough. If we weigh it down with like an example of rain or wind or whatever, where does it cause the most stress in the arches and how can we redistribute that weight? So our engineer actually was the one who assigned all of the shape of the arches. The shapes of them are so specific. And we had a safety or a margin of error. We had to operate within 10 centimeters, a margin of error. So across an arch that spans 19 meters, that's a very small margin. And to do that, we had to create them on the ground and lift them into place with a crane. So if we made them on the ground, we could draw the exact shape of the arch and then be able to lift it with a brace and put it into place on the building. And that was how we figured out to keep the design exactly as it had to be. And this is a shot of actually lifting it into place. After it was lifted into place, then the grid shells were put in place. The grid shells were also a very specific curvature that they had to be. And that was based on the structural model. And the structural model was built from the digital model. You can see right here, this is Alora Hardy, who is the founder of Ibuku and the creative director. And she's holding the structural model on site with her head inside of it. Ibuku does that with all of their models, cut a hole in the bottom so you can actually go inside and feel what it will actually look like and feel like inside. And we built the physical model based on the structural model, the digital one. And then the contractors, the craftsmen, were able to measure the dip in the surfaces of the grid shell from the physical model and replicate that on the building. And it was almost exactly correct whenever they had finished building it. The result is, of course, it's a beautiful structure, but it's a very clever structure, and it's a very functional structure, and it is also a one of a kind. As far as we know, this is the only building in the world, bamboo or otherwise, that uses intersecting arches bound together with anticlastic grid shells. And it's an example of what we can do not only with natural materials, but what we can do with minimal material. If we can create ways of using geometric stiffness and using the shape of a structure to work with the forces within the membrane and within the structural members, then we can actually decrease the amount of structural material that we have to build with. So this is minimalism by nature. It's how do we build the biggest amount of space for the least amount of material? And that's a lesson that can be applied to any material. So that's it for this building. I guess in conclusion, I would say that I think the next steps for this kind of idea, this kind of structure, is how do we create, whenever we can start to understand the rules of a natural material, and if we can convert those rules into formulas, then I think there's a really big opportunity for using parametric design in creating structures like these. If we start testing these natural materials and we realize that there are parameters to them and there's constraints to them, and we start to use that in computational design with parametric design, it could open up a whole new world of what's possible, and also give us new forms of buildings like this one. This is a new shape of a building, a new form in a building, and it's beautiful. And it would be great to start to see more of things that we haven't seen before.
So Roland, like, which tools basically you used while making this project? Like
this one, we used 3ds Max to do the digital modeling.
Okay.
And the engineer did most of the modeling, most of the digital modeling, and computational design was done by the engineer himself. Okay. Because all the arches and all of the shapes of everything were prescribed by him. Mm-hmm. So we would do a test and we would tell him, yes, we can make a curve of this radius, and we can confirm that we can do that. And then he would take that and keep tweaking the structural design. So he did the engineering in Robot. Yeah, okay. From Autodesk. Mm-hmm. And he might have used some other programs, but I know that he did use Robot, and he used AutoCAD 3D for the stick modeling to run the testing for it.
That structural engineer, is he physically present here, or he?
No, he was in. He came to Bali once during one of the later structural tests after the arches were already constructed and erected. But for almost all of the time that he did the structural engineering, he was in Manchester in the UK. Okay. But he's a fantastic engineer. He's the director of Atelier One, which they did the Gardens by the Bay in Singapore. He also, way back, did the structural engineering for the Cloud Gate sculpture in Millennium Park in Chicago. Right. So he's done some incredible work. I think he did Beyonce's Coachella set. He does all kinds of wild projects, and he has taken to bamboo and really has a big interest in bamboo, and we're thankful for that because he's a fantastic engineer. Absolutely. And he was the one for this building.
Nice. So, like, he was a structural engineer, but he was not physically present here, though he coordinated with you remotely directly.
Yeah.
So that is quite possible if you are working with on
Yeah.
such projects.
Very possible.
Yeah.
And we also had collaborators from Colombia that we were
Mm.
working with as well.
Okay.
So we had people from Colombia who had done a bunch of bamboo testing of their own in the efforts to write a new building code for bamboo buildings.
Okay.
And we got in touch with them and they helped us with our research, and we were able to share some of our research with them. So yeah, it was very collaborative across the world, and it was totally doable.
Yeah. There's one question from Sirisha. Can I know which software was used by the engineer?
I know that he used Autodesk Robot, and he also used AutoCAD 3D. And he might have used other ones as well, but I don't know what they are.
Right. So this is a green school. It's in Bali itself, right?
Yeah.
So what was the concept of the green school? Like, this is one part of the green school, right? There's a structure, but the green school is very big. So what exactly the concept, or what exactly the vision of the founder was regarding the green school?
The green school was started in 2008 by John Hardy and his wife Cynthia Hardy. John came to Bali in 1975, and he and Cynthia were able to create John Hardy Jewelry, which is now an international luxury jewelry brand. And they did well with it, and he wanted to fulfill this dream that he had of creating a fully sustainable school. And he decided to make the entire thing out of bamboo, which at the time was a crazy idea, and everyone thought that was insane. But he called the right people and pulled the right people together from all over the world to help and make it possible. He got donors who were able to help fundraise and get things kickstarted, and he did it. He started making this school. He and Cynthia started making this school together that was completely made of bamboo. And it was chosen that it would be bamboo because bamboo is something that is always plentiful, is always going to grow. And he said it was a promise to the students of the school, to the children, that it's something that is reliable, something that will always be around. You can always count on having it available. So that was 13 years ago, and now Green School is it's grown, and it's doing well, and there are children who attend Green School from all over the world. It's a K through 12 school. Okay.
The curriculum would also be different, like they use more practical ways of teaching. Yeah,
the curriculum, the curriculum is like, of course, all of the basics are covered that you would learn in any school in America or Europe, but they have a creative way of teaching in that students learn a lot by doing. Like, for example, actually during the construction process and during the design process, one of the teachers from the school contacted the architecture firm, and he said, I'm teaching a unit on engineering, and I'd really love it if one of the architects from the firm can come in and teach the kids about the engineering that you're using for this gymnasium. And so we said, okay, and I went, and I was like a guest teacher. Yeah, that's me.
Yeah.
And the school used this pavilion that they had as like an outdoor classroom right next to the construction zone. So I was teaching them about the construction and the engineering and the design while they're watching it happen. And they were actually there in this little structure the day that they lifted the very first arch into place, which was very exciting. So Green School has an approach of teaching kids through real life and through actually doing, and I really admire that because I think it's lacking in a lot of schools now.
Yeah, so like this is one of the project on which you have worked on. Like I think there are more other projects as well in Bali or in other places.
Yeah, there are other projects that I've worked on in Bali, but There's one that I worked on, but it's still under construction. So it should be getting done like in the next few months. And I'm sure that you'll see it, on Pinterest or whatever.
Sure. So we'll proceed with the Q&A session.
Yeah.
Yeah. So any questions participants are having? They can directly talk with us. You can raise your hands. I'll unmute you. Yeah. Any questions? All of you can unmute yourself and directly ask. Palita, Anamalai, Palita, she's from Indonesia itself. Yeah. Parasuram, you have any question?
What is the software to be used for the stress analysis?
Yeah, Parasuram. Yeah. Are we audible? Parasuram?
What is the software to be used for the stress analysis? There is any fixed parameters for Bombo?
What?
He's actually trying to ask you, are there any fixed parameters for bamboo structural design or any specific software you have used? Basically, he mentioned before also like the engineering design team have used robot structure analysis. And this is one of a unique kind of structure which have done more structural analysis thing, and they have a different code for it, right?
Yeah, there are some parameters that already exist. Like that Ibuku has discovered from trial and error over time. Like one is that the bottom of your column, structural columns, should be at least 40 degrees or 45 degrees from the edge of the roof. And that is because bamboo is a wonderful material and it's a fantastic material and it has a lot of great qualities to it, but it has one very big weakness is water. You have to keep it protected from rainwater and from flooding possibly. And the other weakness is sunlight. You have to keep it out of direct sunlight, otherwise it will become bleached within a couple of years. So whenever you design structures, if you look at the body of bamboo or Ibuku's work, all of their bamboo buildings in Bali, you'll notice that there are some similarities between the buildings. Like the columns are usually leaning outward, and the roof overhangs very far. And the reason for that is because it protects the column from sunlight and from rain. So there are some parameters, but also those parameters depend on where you're located and what the weather is like where you're located. Here we have rainy season and it pours rain down sometimes and the wind can be very strong. So we have a 45-degree rule. But if you lived in a place where you don't have that issue and you don't have sideways rain, then you might be able to decrease that degree. The roof pitch, it's best, that depends on what roofing material you're using. So like, for example, we use grass thatch roof on a lot of structures here. And for that, you need to have a minimum of 40-degree slope for the roof to get the rain off of it. Otherwise, the grass will not last very long at all, and you'll have to replace it within a year or two. If you're using a bamboo shingle roof, you need to have the roof pitch at least 30 degrees to keep the bamboo shingles from, keep them to last longer. So the higher the pitch is, the longer your roof will last before you have to replace it. So it depends on the materials that you're using. And that's what I was talking about earlier, is starting to understand a variety of natural materials and starting to experiment with them and discovering what are their capabilities and setting parameters around those capabilities.
Right. So I hope Roland answered your question, Parasuram.
Thank you.
Any other question? Yeah. Yes, Shabazz.
Actually, sir, like usually what, am I audible?
Yeah, you are audible.
Okay, usually what happens, we are having a structural member and we like architectural member. So here, what we did, we have used bamboo as a structural member and even an architectural member. Am I correct?
Yes, correct.
Okay, below what I mean to say that substructure, what we did in substructure, like what kind of footing we did
Basically,
below the ground.
here, Shabazz. So you wanted to ask like whether architectural structural and structure they use bamboo for both, right? For the architectural design and for the structure analysis also they use bamboo as a structure. So there were no column, there were no beams at all in the entire structure. So it's a very unique concept and a unique design they have built it on. Yeah.
What about the lifespan of the building?
Lifespan of the building.
For this building, the overall shape of the building is it's in a way where all of the main structural elements on the inside are very well protected from sunlight and from rain, because the roof goes down like almost all the way to the ground. So the only challenge within this building are the parts of the roof on top where it's a very low slope. And that means that those sections of the roof will have to be replaced. And we have to be very careful with those sections of the roof to detail them properly so that there's no issues with water. But with all of that said, other than the top of the roof needing to be replaced more often than the rest, I would say this building will last, if I had to guess, I would say like 100 years. There's just as long as any other building. And of course, there's like some kind of maintenance that has to occur, but there's maintenance that has to occur with any material. Even if you have like concrete walls, you have to, paint them every once in a while and keep them maintained. If you have wood, you have to do the same.
Right.
There's regular maintenance for any building. And bamboo does last a very long time as a permanent structural building material. It is just as valid a material as anything else. And the notion that bamboo is only for temporary structures or only for small or lightweight structures, I think is kind of an antiquated notion that I think is starting to fade away whenever we start seeing more and more projects come up like this one that prove that this is a very serious building material, and it's a great, it holds a lot of great potential.
Yeah, I think Parasuram, Roland has answered your question.
Thank you very much.
Thank you. So thank you, Roland, for giving us the time and taking out the time for all the participants of iWorkstation BIM series. And I hope that we're gonna do a new session one day again. Sure. So thank you all of you for joining. Thank you, Roland.
Thanks, everyone.
Thank you. Goodbye.
Thank you. Bye.